right way. Number 9. Okay, so again, I'm not doing number 9 for you. I just show you how to do it.
In terms of like how much work needs to be shown, I didn't read on that. Is there any extra work needs to be shown?
We're not just doing the drawing. There's still algebra to do.
That's what I'm saying. But when we turn our file over again, do we need to show any work or anything?
Well, there's still algebra to do. So if you don't do algebra, you only get 50%.
The right side is 65.
So you have the drawing and the algebra. So they have to go together. Because the algebra is how you get accurate information. But drawing, make people can see, but not accurately. Oh, this is number 9. Which number is it? For number 9 or number 8?
This one.
Yeah, see, A. So this is the wrong side measurement. See, this is hypotenuse. So that's not 6. The A is 6. See, A is, this is A. Opposite 25. Okay, so that's 6. So this is not 6.
Can I check on 7 and 8 with
Uh,
you? Just to verify this.
okay, oh, say again?
Can I check some measurements with you?
Okay, sure.
Before I finish up my triangle, you had already moved on, so.
Which one is
This is 7, and this was the previous question.
number 7, 3, and 5?
By a hair.
That's pretty good.
Okay.
A little bit off on that one, not too much.
Okay, so work on precision.
And then this is the 10, and then what are the angles? 25 and 65?
I didn't calculate the angles, I just made sure to get the, yeah, or, I didn't calculate the
25 is good.
Yeah.
That's the, let's see, 65. Look a bit off. That's off by
By
1
like a
degree.
hair.
You know, on 1 degree. So that's a hair. It's 1 degree.
A few hairs. Good enough, thank you.
All right. Any question on how to number? Which one is it? Number 9.
Okay, we're not ready.
Yes. So you want 6 centimeters, right angle on the left, 65 angle on the right, and then they connect. That'll give you your right triangle. Yes.
Last part. So since we're turning this in the last day of class,
No way for you to know the grade.
huh?
No way for you to know the grade.
So that's kind of my question. If
I just told you. You just want to be sure you do everything exactly as you can. And so,
I'm pretty sure I'm gonna do it as best I can, but the best I can might not be the best in your opinion. So
well, I just told you, within the 1 centimeters and 1 degree accuracy.
Okay, so that's, so 1 centimeter and 1 degree.
No, 1 millimeters.
1 millimeter and 1 degree is the plus or minus.
That's
the
right.
tolerance on it. Okay.
All right, so next then is, number 9, so number 10.
Hold on, wait.
Okay, so again, the point is you have to know how to do it, and then you go home and you fix it up. All right, so number 10 says, put your calculator into radian mode. So to see what mode your calculator is on, look at the top line, right? So the top line of the screen. So then in this case, so R is for radian. And D is for degree.
Could you paper down just a little? Okay, thank you.
Radian mode is right.
Yeah, you look at the top of your screen, right?
Yeah.
If you see R, that means it's in radian mode. So if you don't see R, you see D, that's in degree mode. Right, so next is, how do you change it?
Thank you.
Right. So to change it, you press mode, except it doesn't give you anything. So to change it, you really have to press shift mode, right? Shift mode. Shift mode. And then 4 for radian. Yeah, so you can do degree, radian, or gradient. Probably, yes. Site notation versus the norm and, right, so press 4. So you can see right there, you have an R on top, so that's for radian. Okay, so when you do calculus, they use radian. So when you use geometry, they use degrees. But when you do trigonometry, sometimes in degree, other times in radian. So when you do solving the equations, it's always radian. But when you draw, it's much easier to draw it using degree because we're so used to degree, left 30 degree, 60 degree. The radian is a little harder to figure out exactly. So when you do drawing using geometry, you use degree. When you do calculus, you do radian. Okay, so there you go. So step 1 is put your calculator into radian mode. So that means step 1, press the shift mode and 4. Okay, so shift mode 4. Right, and then you should have an R on top, right there. Right, so once you've done that part, then construct a table with x value. So you want x equal to -6, -5, -4, -3, -1, 0, 1, 2, 3, 4, 5, 6. Of course, you have to press the mode 7. Mode 7. And then type in the formula sine of alpha x plus 1 inside. Okay, sine, the sin, the key right there, sine alpha x plus 1 plus parentheses. And start equal to -6 and equal to 6. And stop equal to 1. Yeah, start -6 and it's 6. And then you just write down the numbers. So 0.958, 0.75, -0.14, -0.909, -0.84, and then the 0, and then 0.84, and 0.909, 0.141, -0.75, -0.95, -0.27, and 0.65. Okay, so that's like you do a regular graph, except you use radian mode.
How many unit or values can you have in the table? Is there a
15.
limit? 15?
Yeah.
Okay. That's 13.
It's
I'll
just
say
the
that's
limit.
13.
It's just the limitation of this calculator.
Yeah, okay.
So if you get the more expensive one, then they have more memory, so you get bigger. Okay, so next time is plot the points and connect the points. So plot the points and connect the points. Okay, so it says here used 2 squares equal to 1. Okay, so they're not very large, so 2 squares equal to 1. -6, -5, -4, -3, 1, 0, 1. 6. And then plot the points and connect the points. So -6.958, so practically 1. -5.75, there you go. And then -4, -0.14, so down here. And then -3, -0.9, so practically 1. -2, -0.84. And then -1, exactly 0. Okay, so and then 0 is 0.84. And then 1 is 0.9. And then 2 is 0.14, so very tiny. 3 is -0.75. 4, -0.95. 5 is -0.27. And then 6.65. So let's go. So this is the graph of y equal to sine of x plus 1. Okay, so you do number 11 in the same way.
So our graph looks like that, we get 100%.
Well, this has to do with how you place your points. So the accuracy of where you place your point counts.
Oh. Just looks like graphing a polynomial function.
Well, almost, except polynomial, see, look, this has a bound, right? So this is like, it go between -1 and 1. Polynomial doesn't have a bound. So,
Yeah, this was all I was referring to in the notes that I,
yeah, see, see, this is not
in
polynomial.
case anyone else is wondering on the screen.
No, that's not, this is not what I have. This is polynomial.
Okay,
This one is bound, so.
okay.
And so this describes what's called the periodic behavior.
Periodic what?
Behavior. So that means it seems to repeat after a while. So if you look at this part right here, and so this part of the graph there looks like it's repeating on the next cycle as well. Okay, so this right there, that would be one period. Anyhow, so this is for math 104. If you're going to take trigonometry in the summer or the next semester, then they'll do this part. Okay, any question on that one? Okay, so that's done with the drawing. I'll take a 10-minute break, and then we'll do the algebra part when you come back. The algebra part.